All right, IBSL1, we're back to talk about the end of Chapter 11. So Chapter 11 technically had like a couple little geometry topics in the beginning of it, but we kind of skipped those and went straight to the good stuff, talking about triangles. So we first started talking about right triangles. There's a lot of tools for right triangles. The main one that everybody seems to remember and love is the Pythagorean theorem. A squared plus b squared equals c squared. Remember, that only works with right triangles. Also with right triangles, you have this handy, fun mnemonic, SOHCAHTOA, which really just is a way to remember those three trigonometric ratios, like sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. A couple times in this chapter, special right triangles did come up. So we still expect you guys to know, if you take the sine of 60 degrees, that it's root 3 over 2 or something like that. Because that does come up on those special nice triangles, like 30 degrees, 60 degrees, 45 degrees. There was a bunch of word problems that involved right triangles. Usually it was like buildings or like lighthouses that see ships out at sea, or like sorry, I'm getting ahead of myself. We had a lot of 3D shapes came up in this. Like there was pyramids where you guys had to find the angles of certain sides to the base and things like that, but really it was just all right triangles, but it was like 3D right triangles. Then we talked about real-world problems, such as those angles of elevation, angles of depression that involve buildings, lighthouses. There's a lot of different things, but they were all very real-worldy. The common theme with all those is draw a picture if they didn't give you one. Then we quickly started talking about non-right triangles. Something that came up in the last chapter as well as this one is the area of a triangle is 1/2 AB sine C. Remember, that's capital C, where capital C is the angle, and little a and little b are the side lengths of the sides around the angle. Two big laws that we learned were the law of sines. Remember, sine of capital A over little a equals sine of capital B over little b equals sine of capital C over little c. Or sine of any capital letter over little letter equals sine of any capital letter over little letter. Sometimes when you're doing that, I think there was a couple tricky problems where there was actually multiple answers. This is called the ambiguous case. When if they just describe a triangle to you, if it has like a side-side angle, I guess I could write that. This is when you get SSA or ASS. Remember that's how you know when it spells that bad word right there, that it can sometimes be two different triangles. Not all the time. Sometimes it's still just one triangle. But remember, all the angles in a triangle have to add up to less than or equal to 180 degrees. Law of cosines. Remember, it's always in the form of a squared equals b squared plus c squared minus 2bc times the cosine of capital A. There's 3 different versions of that, but it's all just the same formula, just with the letters kind of shifted around. We certainly will have some real-world problems in there that involve law of sines or law of cosines. Maybe they'll involve a bearing. Remember, true bearings. Most bearings, I expect you guys to know, are just true bearings, where you start at north and then you rotate clockwise around a certain degree. Okay, you guys, I posted the chapter review for you guys. Good luck. Use those worked out solutions. Use office hours if you need them.